This video will help you finish the analysis portion of the charging up, charging down activity that we did in class. The previous videos helped us with 1 through 3 in the analysis, and now we're going to move to step 4 in the analysis. And what that is here is redisplaying the graph and using trace to find what's called the half-life of something. The half-life is a time. It's a time that something takes to decay to half of what it started with. And in this case, we're going to find the approximate time at which the capacitor voltage reached half the initial value. And it says here, as you can see in the instructions, that this value is sometimes called the half-life value, denoted T with a small half, a subscript 1/2 there. We can call that T half, I guess, if you will. And so what we're going to do is we're going to find this T half two ways. The first way is by using the calculator's trace function on the data plot, and the second way is by using an equation. So let's cover the first way first here. If you take a look at your data collection, data table, we have T half from graph and T half from K. So right now we're going to just use the T half from graph to be able to figure that out. And what it states here is we need to use the calculator's trace function. So let's go to our calculator again. And you'll want to display your data by pushing the graph button. You should have something that looks like this. And in order to find any value, we're going to use the trace function. Again, the trace is one of the 5 buttons at the very top. Right here we have trace. And if you choose that button there, you'll be tracing, and you probably have your data plot as well as the equation that you created, both graph there. And if you look in the top left of your screen, my screen says plot 1, L1, comma L2. That's what you want to have there. Yours would say P1, L1, L2. You also may have an equation in there. So what we want to do is you can push the up arrow or down arrow to switch between what you're graphing. This would be me tracing along my equation that I typed in. This would be my data equation. I made this one up. You would have your VE to the negative KX. And if I push the down arrow, it takes me back to the plot. So you want to use plot 1, L1, L2 to do your tracing here. And what we're going to do then is we're going to trace along the graph this L1, L2 until you get to that half-life. So your data have all different values here. And if you start at the beginning, again, my initial value is 8.36. You have something else. So if you start with your plots here, plot 1, L1, L2, and you start at 0 and whatever your value is, we're going to use the trace function until you get to half of that value. That's called the half-life for your voltage. Half of 8.36 is 4.18. So you'll want to take your V value, your initial voltage, and divide it by 2. And that'll give you what you're looking for. So what I'm going to do now is I'm going to trace until I get to half of this value. Somewhere around this area here is going to be half of that height. We want half of the Y value. Right now I'm 8.36. I'm going to trace to the right until I get to 4.18 or something as close as I can. So if we trace here over to the right, I'm looking for 4.18. Past it there. This is as close as I can get based on my data. So if I look here, I see my voltage is 4.18, actually 4.19, but that's as close as I can get. So the question is asking you, what's the time? How long does it take until that happens? So if I want to know the time, it's the x coordinate. X is the time, y is the voltage. How long does it take for me to get to half of my voltage? Is approximately 8.64 seconds if I round it correctly. So the T half from graph is by using the graph and using the trace function to get to the half-life, or the half the voltage, and find how much time that took, which is the x coordinate. So in my in my data table, if I want t half from graph, I would go ahead and type in, or you would write in, the 8.64. That would be what I type in. Or you would write however many seconds it took. For me, it's 8.64 in my data. For you, it's probably something else. But either way, that's how you find it. Use the trace function on the calculator to come up with that. Then that gets us to t half from k. That's a little bit different here. T half from k, you're going to use an equation that's given in your directions. And it's an equation that you have not used before. It's this natural log equation here. And the directions say that you can compare the value of t half to the k parameter you determine in the model. So you came up with your own model that you graphed. You came up with a k value. And what you're going to do is you're going to figure out t half using that k. No graphing, just typing an equation into your calculator. And that equation is the natural log of 2 divided by k. And natural log is a new function for you. You don't need to know exactly what it is yet. We're going to study that later. But what we're going to do is go back to the calculator, and we're going to type in natural log of 2 divided by k, and that's going to give us another option for our t half, our half-life. So let's go back to our calculator, and we can quit out of here to go to the home screen. And what we're going to do is we're going to type natural log, and natural log is down here, ironically, conveniently, the same button as the e to the x. They're opposites of one another. So we're going to type natural log of 2, and please make sure you close your parenthesis, otherwise you're going to get different answers than you should. It's natural log of 2, and then we're going to divide by whatever the k value is. And whatever you had there, you can do alpha parenthesis, and that's going to give you k. I believe my k was 0.08. And if you type that in, push enter, that's going to give you an approximation for your t half from k. And so for me, it's 8.66. That takes 8.66 seconds to have half the voltage in that capacitor based on the k value that I had there. And so I can take that value, go to my data table, and t half from k, I can type 8.66 seconds. You would type, or not type, but you would just write those in your data table. And what we're doing there is, once you're done with that, you start answering your questions. How does this half-life compare to the one you extracted from the graph? And you're going to start from there. You'll see that these are very similar, and they should be, depending on how good your k number is. They should both work quite well. But that's going to be the last thing that you need to do to figure out your t-halves, your half-lives. You can just go ahead and use the graph and trace to get the first one, or you can use the natural log 2 divided by k to get the second one. And that's going to fill out your data table, and that's going to allow you to finish up all the questions that you need to answer. Check that out, give it a try, and let me know if you're having any trouble. And good luck completing this assignment.